Okay, let's wait 1 or 2 more minutes in case anybody's running late, and then we'll go ahead and get started. Okay, let's go ahead and get started. So not much in the way of announcements because it's very early in the semester. Did anybody have any questions on anything code related? Okay, so let's get right into it. So out of curiosity, how many people were able to already do the assignment number 1? Most people, right? Show of hands. Okay. I'll try to leave a few minutes at the end of class in case anybody needs help like submitting anything. Not a whole lot, maybe 5-10 minutes at the most. So that it's technically due today, but usually when I do these assignments, I try to encourage everyone to get it done the same day, if possible. Then we have a new assignment, which is probably not going to make sense just yet. This one's due in a week. Now, some of these assignments in the beginning, they're simpler, so I tend to have shorter due dates. And so I know I kind of said before that typically we'll have something due about every 2 weeks, but in the beginning, just so we can get some assignments, some practice, you can get some feedback right away. Some of these early assignments, the due date will be 1 week. But then as we go on in the semester, it tends to settle in around every 2 weeks. Okay. So I'll talk about that near the end of class, but if you have, like a calendar you like to keep, make sure you know that. And don't forget that at any time you can always, under assignments, click the assignment and get more information about it. So in this case, the due date and the number of points. Don't forget that our total number of points in the course will be 100. So what that means is that this is 9% of your overall grade. As I mentioned before, I don't do a lot of quizzes and class participation grades and online discussions and those sorts of things. So your grade is your assignments. That's why they're worth so much, is because I want you to take them very seriously. To me, they're by far the most important part of the course. That also means that if you don't take them seriously, it's very easy to fall behind and fail in the course, because it's not like, oh, this is only 30% of your grade. This is pretty much the bulk of your grade. These assignments are 70% of your grade. So let's open up. There's no questions on anything, either schedule-wise, administrative, or any coding questions at all. I guess we can jump right into it. Just out of curiosity, show of hands, how many people have created one of these accounts on REPL? Okay. Do you find it helpful to be able to get to all your code in one spot? Okay, so let's start off with our normal hello world that we always do. I'm going to make this a little larger. By the way, don't forget that one of the suggestions is to make your fonts very large, because as you're learning this for the first time, you're going to be using a lot of characters and a lot of different keys on the keyboard that you're not normally used to, like curly braces and semicolons and so forth. So it generally helps to be able to tell the difference between a dot and a comma if the fonts are gigantic. Okay, so include stream. And as I mentioned, I always like to start off with just the hello world equivalent. Because what happens is if you try to start writing a more complex program and something happened, like in this case REPL might be having issues, or if you're using another compiler, maybe you didn't set up the project correctly, you can spend a lot of time really wasting time trying to see exactly what went wrong, and you start removing code and taking steps back and taking steps back, and it turns out the project wasn't even set up correctly. You might waste an hour when really you could have immediately discovered that there was an issue. Okay, so that's why I always try to start off with these hello world programs. It's just a good habit to get in, make sure all your project settings and everything are set up okay. There's not a whole lot to mess up in REPL. It's like you just kind of click it, but there have been times where REPL's having issues and I've had to take my code and move it over to a new REPL. And then I apologize, I was a little bit late to renaming the lecture from last week. If for some reason you go to access the lecture and you don't see it there, just send me an email. I'm usually, once I've been reminded, I'm usually fast to rename it. And by the way, the only thing I actually do is just rename it. If you click my name in YouTube, you'll see all the recent lectures, and it'll just have a generic name like live stream. And so if it's like 11 at night and you know I'm probably not going to rename it and you really wanted to watch the lecture, just go ahead and click my name, and then it's usually pretty easy to see which is the lecture for this course. It's the only one that has C++ code in it. So we've already discussed cout and all the different things associated with it. This thing is called a string. This endl gives us a new line. Cout prints text to the screen. And if you remember last time, we also discussed cin. And what does cin do?
Takes input from the keyboard or mouse.
Exactly, yeah. So it does the opposite. It takes input, typically from the keyboard. In this class anyways, it's always going to be the keyboard. And then we also talked about variables. Variables hold data. That data can change. And so let's get rid of this. Let's declare some variables. So we talked about variables, numbers, and strings. And there were two types of numbers. So the simplest was positive and negative whole numbers, or integers. So let's remember, this thing is called a comment. This is a note that we leave to ourselves or another program. It's essentially just notes that's not code. We do 2 slashes, and then everything from here to the end of the line, you can see that it's grayed out. The syntax highlighter knows that it's a comment. And so we can say int, let's say variable age. And here we're declaring an integer, a positive and negative whole number, called age. We name this variable. Don't get in the habit of like calling things x, y, z. Because these programs can grow very large, We want to give these descriptive names so when you're writing code, you actually know what's going on. It's very you can lose track very quickly using names like X, Y, and Z of what each thing does. So that's an integer. Let's say we're dealing with the price of something. The easiest way to think of a double is as a decimal number. Now that's not 100% true. It's very close. There's some corner cases you'll see that's not quite the same, but the explanation is a little bit long. I don't want to get into it right now, but think double decimal number. And as I think I brought this up, other languages actually do have a native type called decimal, and you use that when you're dealing with money because the calculations are always guaranteed to work the way you think they're going to. It's just it works slower. But if you need accuracy, C++ doesn't have that, but there's other ways around it. And then finally, string. But when we use string, we can't just use it. What do we have to do?
Include the header.
Exactly, we have to include it up here. The reason we have to do that is a little complex, but basically these things are called primitives. Int and double are primitives. String is not. String is actually a bunch of individual things called characters or chars. And a char is a primitive, but imagine if you had to work one character at a time. That's not super useful, so what we tend to do in this class instead is work with strings. So I don't type this because I'm going to get rid of it, but string is actually made up of this basic primitive data type called a char, and notice how that is blue. That's an individual character. But again, working one character at a time is not fun, so we tend to use strings mostly in this course. And then we go through this phase called assignment. So we can set age, price, and the name. Now, if you remember from last class, we talked about strings can, and I think we've mentioned this the first lecture, strings can hold essentially anything. Letters, numbers, non-printable characters like a space and the enter key, the asterisk, the caret symbol, left parenthesis, just any character, essentially any, well, yeah, so we'll just say character, any character. So you might think, okay, well, a number is a character. Why not just store everything as a string? Because we can't do things like this. So let's say, for example, we had double as price. We had that as a string instead. You can't do math on it because it doesn't really make sense, like Alice times 2. And it doesn't know the difference between a number that's a string and a bunch of characters. A string is a string, so it doesn't matter if it says Alice or if it's a bunch of numbers. To the compiler, it's just a string. So we can't do math. Comparisons get a little bit more difficult. So that's why we have these native numeric types. It's because when we want to do arithmetic, certain types of comparisons, and so on. And then when we use them in cout statements, we would say, we just use the variable by itself. Oops. Can everyone in the back see that okay? Okay. Okay, any questions on that? Is that pretty clear so far? Does anybody need this up for another 20, 30 seconds or so? Can I switch to a new example? Okay. And by the way, if for some reason it's not compiling or you're just having a problem with it, normally I would have stopped the class and walked around to help anybody. But because it's like a hybrid format, we're a little bit crunched for time. So what I usually suggest is stay after class and I can help you, or under class examples, I always post gets around to it, the source code. Like for example, here's the source code from last week. Okay, so let's open up a new REPL here. Still a little bit more review. At first, I do like to spend a lot of time reviewing because all this stuff builds on each other. So if you're in week 5 or 6 and you don't remember how CN works, you're gonna have a really hard time with the rest of the course. So it's not like other courses where maybe some chapter doesn't quite make sense and you can kind of get around it and maybe study for the final or something like that. But in this class, everything builds layer by layer. So it's very difficult to not understand a concept and move on. So I try to do a lot of review, but once we get later in the course, I'll stop with the review and we'll focus more on new things. So let's do an example where rather than hard coding values inside of assignment right here, we take in as input from the user values. Imagine and so the process of actually running your program, it's a little bit hidden with REPL, but we actually go through 2 phases. We compile the program to a binary, so say for example like an exe file, so we compile it to our exe file and then we run it. What happens, and actually you can actually see that right here. So this is the command. It looks, they basically create a Linux environment, REPL does, and then you get your isolated Linux environment. It's actually running commands in the background. So here's our compiler's Clang, and here's the entire command. And then you can see here, after it's compiled, the program is called main, and it runs main. You can see there's 2 distinct steps here. Now, when I run the web browser, they don't give me the source code with it. I mean, if it's open source, yeah. But let's say, for example, Internet Explorer or Edge, I think now. They don't give me the source code with it. What if I want to go to a website? Imagine if I had to go into the source code, type in my website here, recompile it, and run. That'd be a little ridiculous. So what do we do instead? We can dynamically get inputs from either the user or some other source. In this class, it's just going to be the user. So to do that, we use cin. So let's say, for example, we've got our GPA. And let's also, just so we get some more practice, we'll do a string. We'll do name again. And remember, when we use strings, we have to include up here. So we've declared 2 variables. We've declared a double, and we called it GPA, and we've declared a string, and we're calling it name. Now, usually this follows some sort of pattern where we ask the user for something. So we might say, enter GPA. And then we follow it by a CN, where we say, okay, stream from the keyboard. Notice that the arrows are going in the other direction to GPA. You run it. Now, one very common mistake is that sometimes people get a little bit too wrapped up in the patterns of things, and they'll add endls here. Just make a mental note that endl doesn't really make any sense in the context of a CN. Endl means end line, which you've already hit the enter key. It's all captured and the data is going this way. It's taking from the keyboard and it streams it over here to GPA. So we just do this. We just take it, the data from here and put it over here. And then we can say the same thing with name. And we go ahead and run it. Not much is going to happen because we're capturing the data. So it's stored inside of here, but we haven't done anything with it. So just to echo it back to the user, we might say, hello, name, GPA is. Now, I specifically chose a very long cout statement because if you remember, we can split these up into multiple lines. Now, on your screen, it might not be as bad, but typically in programming, we want to avoid a couple of things. We want to avoid many things, but two of the things that we want to avoid is line wrapping. Notice how it's wrapping around like this. Now, if it's going to line wrap, usually you want to have some control over it. And so what I typically do is something like this, so that at least certain things line up. Notice how this lines up at least a little bit better. And the reason we can do this is because every regular line of our code ends in a semicolon. And so when the parser is reading this, it reads and reads and reads and reads. It sees that you hit the enter key, but it didn't see a semicolon yet, so it keeps on reading, keeps on reading, keeps on reading. Same thing happened here. And all of a sudden, now that I hit a semicolon, I know that's the end of your line of code. And the other thing is, even if it doesn't wrap, it's generally a bad idea to have very wide text. I'm not a medical doctor or biologist, but I've read some articles that your eyes generally aren't very good at scanning long distances left and right. Your eyes are better at reading narrow blocks of text up and down. And that's why you tend to see a lot of coders, even though you have a very, very wide screen, a lot of times code actually only takes up a very narrow portion of that. Now, I don't know if that's true, but I've read several articles about that. That's why you want to keep, and it's for websites as well, is that if you've got text on the screen, you kind of want to push it to some narrow range because your eyes aren't very good at scanning very far left and right versus they're much better at reading top to bottom like that. Could all be a complete lie, but I've read it somewhere, so. Now, that also brings up the point, even if you might think, oh, that sounds like a complete lie. A lot of times when you're writing your code, you just kind of do what the other programmers do. In very large projects, there's usually like style guidelines because you might have 20 or 30 people working on the source code. And what you don't want is to be able to open up a file and say, oh, that looks like Chris wrote that code. You want to make it so that everyone's code kind of looks the same, and then you've adopted a style to your code. Okay. So any questions on CN? Does that make sense to everyone? So again, the summary, just the arrows are going in the other direction because you're getting input from the keyboard, and you're storing it over here. Okay, so let's get another example going here. As I mentioned previously, I really like doing these conversions because they're not mathematically, they're not very tough, but they do allow us to go through some, like whatever thing we're trying to learn in the language. Like right now we're learning variables, and so it's a good chance to showcase variables. without getting too caught up in the actual problem. So let's say this program is, I don't think we've done miles to kilometers yet, have we? I think we did liters and gallons and some feet to inches, but that doesn't ring a bell. Okay. And I like these because they're generally pretty simple. It's just one number multiplied by another. So we could do 1 mile to km. And so it's saying we just multiply by 1.609. That seems simple enough. When we're working on a problem like this, one of the first things you want to do is identify the data that you're going to be working with, because often that results in a variable. So what do you think the two variables are going to be? And what's their data types? So first off, name the variables that we might want to declare.
Miles and kilometers.
Exactly. We're going to be dealing with miles and kilometers, and we don't want to hard code them in the program. We might want to do some calculations. We might want to ask the user for the number of miles. So we want to avoid, by putting them as variables, we have a little bit more flexibility. And then what are the data types for those two? So obviously it's a number. Our two choices are integer and double.
Doubles.
Yeah, so who says integer? Show of hands. Who says double? So those that say double, give me a reason why.
Because when you're between miles, 1.5 miles, 1.6, that decimal is
Exactly, yeah. So if we had declared it as an integer, a user couldn't enter in 1.5 miles. Be kind of a useless, not completely useless, but not super useful converter. So we're going to have double miles, double kilometers. One thing, so sometimes I forget to mention some minor details. Somebody in the other section of the class asked if there's a difference between, say, capital M and lowercase m when we're declaring variables, and there is a difference. So if I were to try to do this, so don't type this, I'm going to get rid of it. Notice that it's complaining, because it's case sensitive. Capital and lowercase are different things. For this class, right now anyway, do everything, all your variable names lowercase. There's a reason. It's because when you start using capital letters, that means something special. It means either it's a class or it's a constant, or it means that there's something special about it. And somebody's going to read your code and they're going to think, oh, they used capital letters. They must be dealing with a constant, and it's not. And it gets confusing. So for right now, even though it may seem off to you, just do everything as all lowercase. Okay. So the first thing, if we're converting miles to kilometers, we have to actually get the data from the user. We have to get the number of miles. So we say cout, enter miles. Now remember, I'm not using the end line, and there's no magical reason other than when the user is entering in their input, it kind of makes sense to have the cursor on the same line. So it's just as simple as that. There's nothing that interesting about it. To me, it just makes it a little bit easier on the user. And then once we have the number of miles, we're going to calculate the number of kilometers because we can say, okay, they gave me the number of miles, and I just know from the formula that it's the number of miles times 1.609, and then we can output the result. Oops, we have to actually put the number of kilometers, km. And, So now for your assignment, what you'll have to do is a similar one of these conversions. And I give you the link. So create an interactive program. By interactive, I mean that you have to get the input from the user. You have to use CN. You can't just hard code things like we did in this example. You have to actually use CN, just like we did here. And we're going to convert Fahrenheit to Celsius. So that you're going to ask the user what their temperature is in Fahrenheit. Now, because Fahrenheit's a very long word, and I've noticed using this assignment in the past that a lot of times people misspell the word Fahrenheit. Just use C and F as your variables, okay? Because a lot of people misspell it, and in the real world, you'd probably use the full word, but because you're just learning, and it's very easy to make small typing mistakes, and yeah, that's mainly the reason, is just to avoid small typing mistakes. So just use C and F as your variable. So you ask the user for what their temperature is in Fahrenheit, store that in the variable F, and then convert to Celsius, and then output that. Now, this one's a little bit more complicated because it's not just one number times another. There's an equation. It's very simple, and I give you a link here. Now, they give an example calculation, and as is, this isn't going to work. So that we can't do that as code. Now, remember that this is algebra right here, but we have to convert this into code. So let's start to go through and convert this to code. Well, they gave us an example of 50 degrees Fahrenheit, but we're going to be using a variable. So we may take that and say, okay, well, they've supplied 50 degrees, but that's going to be our variable f. Now, in programming, we don't use the x. What do we use instead for multiplication? The star or the asterisk. Now, again here, they've given us an answer. They've done the calculation, but we don't do that. We do here. Now, what's wrong with this? We're very close, and let's say we added a semicolon. Is this valid C code or C++ code? Any ideas? So I'll give you the answer. It is not, and why?
You haven't identified the variables.
Well, that too. And so say we already had done that. Remember that this is not algebra. We always have to do. This is like saying this is like a balanced equation. In programming, it's actually what's called assignment. So what we have to say is that we have to say this. What we're assigning to always has to be on the left-hand side. What we're going to do is we're going to calculate this. The user is going to supply f. And then we're going to store it over in this variable c. Does that make sense to everyone? So even though the other equation was valid algebra, we're not in algebra right now. And as I mentioned previously, there are actually some programming languages that, to show you you're actually doing assignment and it's not like a balanced equation, they'll use something else like an arrow or something like this. I personally like this arrow because it really says what's going on. Obviously, this isn't valid C, but other languages do this, that it calculates a result on the right-hand side and then stores it over here. But this is what we're stuck with, so it's just something that you have to make a mental note of. Okay. So that's the assignment. Now we're going to do other things today. We're going to talk about if statements and so forth, but that's all I'm expecting for the assignment is just something similar to this. Now I will make one note, and I'm going to say this a bunch of times, and somebody always does it. Do not do 5 divided by 9. Do not do 5 divided by 9. Do not do 5 divided by 9. Use this approximation, this 0.5556. If you try to do this in code, it's going to result in something called an integer division, and it's very sensitive to the way you write the equation. So it may even seem like it worked, but if you move things around even slightly, it'll break. I'll spend about 20 minutes explaining integer division at a later point in the course, but I don't want to right now because it's not super complicated. It's just not. If statements are more important right now. So I'm saying this multiple times. Do not use 5 divided by 9. I will mark off points, and you might get really upset about it. It's because integer division is special enough that I want to cover it on its own. Okay, so just stick with this, and you'll be fine. Okay, so that's the assignment. Don't start to work on it now. I'll give you some time at the end of class to get it started. I want you to make sure that you pay attention to the other things that we're going to do right now. Okay, so let's do another example here. I don't think we've done area of a rectangle yet, have we? Okay. Sorry, I have many classes that are similar, a lot of different programming classes, and they kind of work at different paces. And some of these examples I reuse because some of them it's like language agnostic. So that's why you'll hear me ask that sometimes. So it's 4. So getting some more practice doing these very basic calculations. If I wanted to do the area of a rectangle, now the area of a rectangle is just the length times width. So we know we're going to need those two things, and obviously that's not doesn't work very well as a string. What do you think it works better as, an int or a double? How many people vote for double? Show of hands. How many people think it works better as an int? How many people don't know? Okay. So it probably works better as a double. The reason being is because somebody might have like 2.5 units. Okay. It probably seems like we're using double for everything. Why not just use double for everything? We're going to get to, by the end of class, we're going to get into reasons not to use a double. Okay, length. There are certain restrictions on a double. There are certain things that you can't do. So there are times that you have to use an int. And I think if you really wanted to get into the internals of the computer, I think integer arithmetic tends to be faster than double arithmetic, but that's if you're doing like very, very high speed things. And then there's other reasons as well, like double you can't really use for money, so there's ways to make integers look like money. Like anyway, okay, so just as before, we've declared these variables length and width. We want to get that information from the user, so you'll see this pattern over and over again. We're going to ask them to enter the length. And then we're going to store that somewhere. Same thing with width. And then we want to say area is length times width, but what did we forget? It's complaining. Why is it complaining? By the way, I'll do this every once in a while. It'll introduce mistakes or things we forgot, because this is how you write real world code. You don't always write it correct every single time. Actually, in general, you don't. Usually, you make some mistakes. So what did we forget? What are we missing? So let's try to interpret our compiler error. Error, use of undeclared identifier area. So it's saying area is undeclared. So what do we have to do to declare it?
Add a double area.
Exactly. Now there's two ways we could go about this. We could add it here or up here. There's two different schools of thought. Old C programmers like to put everything at the top, declaring all the variables in one spot. There's another school of thought, put it closest to the place that you use it. Let's, for now, just so we're very organized, we'll just put it at the top. Once you get into more complex programs, you'll see why it would make sense to declare things a little bit further down. But just to let you know, you don't have to put it up here, but in this case we are. And then let's add a cout statement at the end that says area is So since we're doing good on time, let's take 3 or 4 minutes, and I want you to extend this program that rather than finding the area of a rectangle, I want you to find the volume of a box. And how do you find the volume of a box? It's length times width times height. So go through that process mentally. How would you modify this to, instead of finding the area of a rectangle, find the volume of a box? I heard the typing slow down, so that's my unofficial cue to move on. Okay, so we're going to have to collect the length, the width, and the height from the user, so we're going to have to introduce a new variable, right, because we're going to have to store this data somewhere. And now, following this pattern, we're also going to want to ask them for the height. We're going to have to store that somewhere. See if I can get this all to fit on one screen. And then we're no longer working with area. Now we're going to be working with volume. And we need to change it in all the different spots. And then, as I mentioned, volume is the length times width times the height. Okay. Any questions on that example? So at the end of last class, we started up with if statements. And the idea of an if statement is it's like a conditional piece of code. If something is true, the code runs. If it's not true, the code doesn't run. So let's go ahead and do an example with that. So let's do a sales tax calculator. So if we're calculating sales tax, that means that the user is going to give us the price of the item. So we'll say double price. And then we're going to calculate, so we have the sales tax as a percentage, say 7%, and then we're going to calculate some tax amount. So let's say double tax price, I guess. I don't know if I like that variable name, but notice that if we have a multi-word variable, what do? We put an underscore in between. We can't use spaces. Now, just to let you know, our naming convention, so this is called snake case, by the way, like the animal. I think they call it because like if you look at it like a snake, versus the other one's called camel case. I don't want to get into the names too much right now, but our requirements are that we can call things variable names, any letters, numbers, or underscores. And then the one requirement is that we just can't start it with a number, because then the parser doesn't understand the difference between the variable and a number. So if we did like, notice that it's complaining about that, but if we had put it at the end, it wouldn't complain. Okay, so just a minor thing. In general, if you just kind of stick to your intuition of how we name things in class, you usually be all right. Okay, so we want to get the price from the user. And then we can calculate the tax price is equal to 0. So that would be 7% times the price. And then we can say cout tax is so if we do $1, it should be 7 cents. Now the issue that we run into is I can enter in minus $5. Now it's going to do the math, which is correct. You have a negative times a positive, right? This would be the positive, and then price was negative, and then we get this back, but it's kind of like a nonsense answer. Maybe like in accounting or something, the idea of a bill of negative $5 makes sense. But for most people, that doesn't really make sense. So what can we do? We can wrap this whole thing in what's called an if statement. And it's conditional code. So if, and then we have some condition. And in this case, we're going to say the most common conditions are just simple comparisons, greater than, less than, equal, those types of things. That's why we do a lot with numbers, is because numbers are very, you can naturally compare those. So what we're going to do is the price that they entered in, if they entered in a number greater than 0, if they entered in a price greater than 0, we run the code between the curly braces. Notice how I indented as well. This is a readability thing. We'll get into some of the details later, but for right now, know that anytime you use an if statement or anything like it, anytime you see these curly braces, indent one level. It's what's called a code block. And we go ahead and run it. And if I entered in $1 now, that works. I entered in -1. Well, that sort of works, but we kind of want to get the user some sort of feedback to let them know that they've entered an invalid price. So we have our if statement, and it goes if the stuff in the parentheses is true, run this code between the curly braces. Else, otherwise, in all other cases, means that they didn't enter in a number greater than 0. So tell them that they've entered in an invalid price. So your book has all the different comparison operators that you can use, but I'm just going to Google it real quick. So these are the ones that we care about. So we just talked about greater than, and your intuition for less than is probably correct. The couple that are maybe a little bit different, if I want to do greater than or equal, this is the symbol I use. I use the greater than, equal. If I want to do less than or equal, I use that. Now if I want to check that two things are exactly equal, I use two equal signs. Notice that I don't use one equal sign, because what is one equal sign? That's what's called assignment. This is more like you're used to with algebra, checking that it's like a balanced equation, that the thing on the left is equal to the thing on the right. One equal sign means I'm taking the stuff over here and I'm assigning it to this variable, which actually exists concretely in your computer's memory somewhere. And this exclamation point means not. So if you want to check that two things are not equal, we'll probably do an example at some point in the course with that. Okay, your book should have these. If not, it's a pretty easy thing to find on the internet. Okay, so any question about this? So we can use these if statements. Oh, let's do one more thing just to show to you that, okay, once you're done with this else, whatever's outside of these curly braces, that's going to run, you're back to normal code operation. You're not in like a conditional execution. It's just going to run no matter what. So if we wanted to do like a end of program, whether I put in a valid price, notice end of program, or an invalid price, end of program is always there because it's outside of the if else. Now, one thing that I do see some people make mistakes with is that you can't put any code between them because it doesn't really make sense. It's all together as one logical unit, so I can't do this. This wouldn't compile, it would complain. Notice that it's saying something's off here. Okay. Okay, any questions on that? So let's do an example where we're using these double equals. Now, one of the cool things that you can do with these double equals is you can make menu-based programs where you might ask the user, okay, do you want to do this thing or this thing? And you say, okay, if the menu choice was this, do something. If the menu choice was this, do something else, and so on. We'll be up to here, 1, 2, 3, 4, 6. So let's say, for example, I wanted to do a program where I could go from either miles to kilometers like before, or kilometers to miles, and let it be up to the user which we want to do. Now I'm going to write some of this code without explaining, and then I'll explain it at the end. Okay, so I'm telling you that this is going to be a menu-based program. So the user is going to have to input and tell us a choice. So we're going to have an int choice, and I'll explain in a minute why we chose an integer. And then we can give them a simple menu. We can say, press 1 for miles to kilometers. Press 2 for kilometers to miles. And then say enter choice. So you might ask yourself, why are we using a number instead of a string? The reason being is because just historically, numbers are very easy to compare. Imagine if I had them enter a choice as a string. What would they enter in? The full words, miles to kilometers? Well, the problem with that is that it's case sensitive. So depending on if they make a typing mistake or, there's a million different ways they could make mistakes. But this is very discrete and concrete that this is choice 1. It's very hard to mess up the number 1. It's only, there's no such thing as a capital and lowercase 1. It's a single key on the keyboard. So the reason we chose it as an integer, there's 2 reasons. We'll go over the second reason in a moment. Could somebody enter in choice 1.5? Would that make sense? No, they're very discrete choices. It's 1 or 2. And if you had 10 menu choices, it'd be 1, 2, 3, 4, 5, and so on. Okay, so how do we know which choice they entered in? What we'll do is we'll say, okay, if choice is, and remember from earlier we saw these 2 equals, they mean if choice is equal to 1. Single means assignment. Notice that it's complaining and it says you probably don't mean assignment here. Double equals means that it's equality. Okay? So we'll say if choice is equal to 1, and then this is a very straightforward, I'm actually probably just going to steal the code from before, just so we can speed things up just a little bit. Which example was it? Here we go. So it's 1.609. So if we're going miles to kilometers, going back up here, we know, okay, we need miles and kilometers. And then we're going to say, okay, well, since you entered in choice 1, you probably mean to give us the miles. So we say enter miles. Store it in miles. Do our conversion. And then see out. I'm sorry, I'm going a little bit quick. We've just already done this code before, so it doesn't need too much explaining. And we'll probably finish in the next 3 or 4 minutes, which isn't a whole lot of time to start the assignment, but at least you can read through it and kind of wrap your head around it and make a plan. Now, what if I enter in choice 2? Nothing happens. So, and there are some issues with this. I like to introduce things one at a time, so some of you might see the issue with this. Some of you already know how to code. But I can say else, okay, cout, enter kilometers. This is just stuff we've done a bunch of times before. Cin to kilometers. Then the number of miles is going to be equal to the number of kilometers times some number. Let me look that up real quick. do times this. And then miles is so this works, but what's the problem? It thinks that everything else is kilometers to miles. What if I enter in choice number 5? It still thinks we're doing kilometers to miles, which isn't correct. So we can learn something new called an else if. So we can, rather than just having a catch-all, we can say if choice is equal to 1, else if choice is equal to 2, now if we enter in something like 5, it didn't assume that we meant kilometers to miles. But it silently didn't say that we entered in an invalid input. So we can chain these together. We can have an if, else if. Actually, we can have as many else ifs as we want. If we had 5 choices, we could have else if choice 3, else if choice 4. In this case, we only have the 2. And we can have a final catch-all if it's none of the other choices, which in this case it's only 1 and 2. We say else invalid input. So now if I enter in something invalid, like 5, we just get an invalid input. We'll go over a couple more menu-based examples at the beginning of next class. This was just to kind of introduce and get, yes? We'll actually go over that class. There is a difference, and it's kind of difficult to see here, but we'll do some examples next class. That's actually a very good question. Now, one final thing that we'll see next class is I chose an int. You might again think, why not choose a double for everything? You can't do this comparison when you use a double because there's some magical stuff that happens at the CPU level with how floating point numbers work, and we'll see an example of that. But just know for now that if you're going to use the double equals, you cannot use anything, you can't use a double. You can use an int or a string, but you can't use a double. And it may not be obvious because it'll still compile, and sometimes it'll work, and then sometimes it won't. So I'm just kind of telling you as a rule right now. We'll get to all this stuff in later classes. Yeah, did you have a question? Or were you just stretching? Okay. Okay, but I think that's enough for today. So just kind of, I know it's not a whole lot of time, but just take a few minutes to read over the problem for the assignment, make a plan, decide how you're going to solve it, and that should be it. So any questions that you might want recorded?